All right, it's recording now. Okay, let's go back. Sorry about that. So um, kinematic viscosity is given for water at 20 degrees Celsius. Kinematic viscosity is given as 1.004 times 10 to the power of minus 6 meters squared over second. Now, what is the relation? If I'm not mistaken, last time in our pipe flow, right, we use rho VD over nu. Okay. Now, oh, sorry, over mu, mu, mu is this one, this guy here. Just a second, I'll just use laser pointer. So this is mu, mu, Um, last time we have a formula of V rho D over mu. So actually, nu is mu divided by rho. All right, you'll get nu. That means kinematic viscosity is dynamic viscosity divided by density. Um, this is just to simplify the formula. I could write this as rho VR over dynamic viscosity, which is the mu lah. All right. Now, Reynolds number is a dimensionless number. That means it doesn't has a unit. It doesn't has a dimension. So, right. So now, I of course you can guess what unit nu would be. This is meter over second. Velocity is meter over second times a meter. Your hydraulic radius is in meter, so you have meter squared over second. So by right, since you know Reynolds number has no unit, okay, so your kinematic viscosity would be meter squared over second as well. All right. So now how do we classify it? Remember last time in your pipe flow, like you have this Reynolds less than 2000, the limit. Uh, Someone is switching on the. Wait, I'll need to mute. Wait, Okay, it's mute already. Okay. Now remember last time, right? When you learn about pipe flow, the limitation will be 2000. There is a factor of 4 there actually. So now the limit for laminar, transitional, and turbulent, if you look at this, right, is actually, are you able to see my slide? Still,
Yes.
Okay, great.
Yes, yes.
Yeah. All right. So if you look at this open channel flow, Reynolds number less than 500 is laminar. Between 500 and 12,500 is transitional. And Reynolds number greater than 12,500 is turbulent. All right. Now, I think I'll change this for me to teach it easier is okay. So, all right. Okay. So now, let's see Reynolds number, the formula. If you look at this, the numerator is the inertial force. The denominator, all right, would be the viscous force. If the numerator is greater than the denominator, which is the third case, turbulent, you know that the flow has high velocity. So it is turbulent. If, this kinematic viscosity is greater, considered to the or more dominant than this your dynamic force or your initial force, then you know that your flow has less velocity, so it is laminar. Last time I believe you have already conducted the experiment of Reynolds number where you put the dye and you look at the flow, right? When the dye is flowing, right, almost parallel to the line of flow, right, that would be lamina. And then if it's, it's go haywire, right, the dye color, is turbulent or between transitional and turbulent. All right, that is how the experiment actually tells you lah. All right. Um, Actually, I'm not sure whether you are interested in, just now when I told you, right, there's a difference in pipe flow and open channel flow. Let me show you some, I'll just explain something to you. So I'm going to stop this first. I'm going to share. All right. Now, you know, okay. Last time you learned about Reynolds number as well. Last time you learned about Reynolds number in pipe flow. So today we are going to look at open channel, open channel flow. So last time is pipe flow. Okay. Now last time when you are using D, it actually stands for diameter, not the hydraulic depth. In our syllabus, we learned that D is equal to A over T, but last time your D is the diameter of pipe. All right. So D is diameter of pipe. All right. Now, this time, our Reynolds number, we use the hydraulic radius, which is R. All right. Um, okay. R, we know, is the flow area divided by the wetted parameter. Okay. Now, what I'm going to show you would be what if, all right? Last time your Reynolds numbers is using D. This time our Reynolds number, we are learning in open channel flow, so we are using the hydraulic radius. So therefore, if I want to, use the same formula, the R in pipe flow, right? What would happen then? Or I'm going to use this diameter, all right? In open channel, so I'm going to have, so if for pipe flow, the hydraulic radius would be, my A would be pi d squared over 4, right? This is my A for the pipe flow, and then my P would be pi d, all right? So I'm going to combine this, simplify this, I'm going to have, so I'm going to cancel this. Now, what I'm showing you is R is actually D over 4. Now, that is why last time, when you have this lamina, um, this lamina limit, right? Last time we said less than 2000 would be lamina in pipe flow. This is pipe flow. So this time, this is open channel flow. Our Reynolds number is less than 5 because I already considered this, you know. So that's why I hope it's actually the same Reynolds number formula. It's just that last time we are using the diameter of pipe. This time we'll use the hydraulic radius instead of the diameter of pipe. So let's go back to our slide. Okay then. Now, just now we have looked at the effect of viscous force, right? The viscosity force. Um, Now we are going to look at the Froude number, which actually look at the effect of gravity, or the gravitational force. Now, based on gravitational force, the flow may be classified into subcritical, critical, and supercritical. Now, you should know that when I say supercritical, that means the flow is flowing with high velocity. Compared to subcritical, right, the velocity is less. Now, let's look at the formula for Froude number. So, Froude number is the average velocity divided by square root GD. V would be the initial force, square root GD will be the gravitational force. Now, this Froude number has no unit. It's also a dimensionless number. Um, Now, in this case, D is a hydraulic depth. Be careful, because we are in open channel flow. So D will be hydraulic radius. There's no more, unless it is stated. For example, I think in your quiz, right, I state there the diameter of the circular channel. All right, is given as such. So you can use D in there. All right. So be careful. I hope you can distinguish lah between those D, right? Those two different D. Of course, gravitational acceleration, we are using 9.81 in our class. So now, look at this. What I'm trying to mention here, if you look at the formula, right, Froude number is V over square root GD. What if velocity is less than square root GD? That means you know that your velocity is small compared to your gravitational force, right? So the flow would be in subcritical state. If the velocity is very high compared to square root GD, you expect the flow to be supercritical state. That's why your Froude number is greater than 1. If velocity is exactly equals to square root GD, then the flow is in critical. All right. So now, of course, based on what we have learned just now, all right, we have, if it's greater than 1, Froude number greater than 1, Reynolds number greater than 12,500, so it is supercritical turbulent. If it's greater than 1, Reynolds number less than 500, this is laminar, this is supercritical. So your classification would be supercritical, laminar. All right, and so on. Last class, I asked you to try this on. Before that, if you look at this diagram here on the top right side, um, this would be the slope of the side of the channel. For example, you have triangular or trapezoidal channel here. This is called side slope. Because students always get confused when I said side slope. They thought it's the longitudinal slope. The word long, of course, is along the channel, right? So it's on the longer side. So that would be the longitudinal or the bed or the channel's bottom slope, right? That is the longitudinal slope. Now, because in this activity 1.4, right, we are going to I guess there's a length of channel given, which is this length lah, right? Which is the longitudinal length. Now the question asks us to find top surface width, flow area, wetted parameter, hydraulic radius, and hydraulic depth. Of course, let's do this together. I believe some of you have already tried this out. So let's check our answers. Okay, now you have this question here. This first thing I want to ask, okay, we have 67 of you are here. All right. Since I have 67 of you here, I would like to ask Adib Irfan. Is Adib Irfan there?
Yes, Doctor.
All right, Adib. Adib, can you tell me what would be the Z here?
25.
Ah, so fast. Great. Thank you. You have the answer already, is it?
Yes, yes.
Okay, great. How did you get this, Irfan? How did you get 25?
4 over 100.
Yes.
Lepas
Okay.
tu kita kecilkan.
All right. This when
Jadi
you
kalau
want to
satu,
change this to one, right? You divide by
yes.
4, right? Okay, great. Okay, that is how. So Z would be when this vertical scale is 1. Okay, how about this, Adib? Continue, please.
Uh, Z 100.
100. Okay, great. Thank you. I hope the others understand. So of course this is automatically Z would be 2, Z would be 3. Now I would like to ask Adlia Izati. Adilia. Are you there, Adlia Izati? Okay. Maybe she's not in front of the computer. How about Wei Jing? Chai Wei Jing? Wei Jing, are
Yes,
you there?
madam.
All right. Wei Jing. Um, here's the thing. You have this channel section here. How many parts you want to divide it into?
5.
5. Okay. Um, okay, you are going to divide it to 5. So what is your 5 here? You are going to divide into here like that, is it? That means you have a rectangular, then triangle, rectangular, triangle. Am I right?
Yes.
Okay,
Yes.
that would be 6, I guess. 1, 1, 2, 3, 4, 5, 6. But what I'm going to do, okay. I know my solution. I think I have divide into 6, I guess. This time I want to divide into 2. That means 2 trapezoidal sections. It looks simpler, right? Because you have the formula of trapezoidal also already, right? Okay.
Yes.
Um, Oh, I think probably you cannot. I understand why you want to divide it because the side slope left and right are different, right? Wei Jing, now I know
Yeah.
why. Okay, great, great. Okay, it's fine then. All right. So, but still, you can solve it using the trapezoidal formula because you understand the concept already. The z should be different, but okay, I'll follow your, what you want to do. So we are going to divide into 6. All right, subsection here. Now, here's the thing. Let me put this as subsection 1, 2, 3, 4, 5, and 6. So I need some help. Okay, I need some help from you guys. Um, Now, let's just solve for the top width first. Okay. Um, I want help from Farah Huwaini. Is Farah there?
Yes.
Okay, Farah, can you tell me how are you going to get the top width?
Sekejap eh.
Okay, sure.
For yang first tu ke?
Yeah. Give me this one first.
Oh yang tu.
Farah betul tak ni?
Sekejap kejap.
Okay, tak apa, tak apa. Take your time, take your time. The others help me as well, ah. Yang lain pun tengokkan, eh.
Betul-betul.
Betul, eh?
Z1.
This
ZY.
one 0.6 meter because it's given 3.6, right, total. Okay. So,
Ah,
betul. Macam ini, Huai ni sambung?
yang tu dia yang tu sama juga.
Sama kan?
Z1.
Okay, so
ZY.
tapi saya guna dua lah kan, subsection 2.
Dua.
Ini
Yang tu
B1, eh?
B1.
Okay, thank you. Yang this one?
Z Z3 Y3.
Okay, good. And then finally I have?
Z6 Y6.
Alright, thank you.
Alright.
Alright, okay. So, um, it's simpler as that, right? It's very simple. So, we are going to write this one lah. We are going to write this down. Z5 is 100. Y5 is Y5. The depth of what of subsection 5. Gordon Chan. Gordon Chan.
Mm.
Yuan Ping. Yeah, Yuan Ping. Can I have what the depth of 5? Subsection 5?
0.6.
Okay, great. Thank you. So Y5 and Y6 should be the same, eh?
Yes.
Okay, great. So Y2 would be? What is this step?
3.
The 3. Great. Thank you. Gordon, are you still there? Can you help me solve this?
The answer is 130.
130, yeah?
30, yeah.
Anyone has different answer?
120.
Okay.
Doctor,
Yes?
the Y6 is 25. The Y6 0.6.
Correct. That's why. Thank you. You're right. That's why I think the depth, I just informed you guys, right? The depth should be the same, right? So this is 120. No wonder. Okay. Now you understand, eh? Alright. So this is 120 meter. Now, you have that. Then the next question would be, we need to
Doctor.
find our flow area.
Doctor,
Yes.
how about if I only take the T of 5, 6, and 4? Is it wrong? But I get the same answer too.
Yes. Correct. But you can find 5, 4, and 6. You still have to find this, right? The 4 one, how are you going to find 4 one? You still have to find this, right? Am I
Yes.
right? The same thing. Agree on that? If you
But
want to find, okay, it's still the same thing. Alright. Now, you may have your own way, but it doesn't matter. Alright, you come back to 122. Alright, there are so many ways to find this. Alright. Now, I'm the type who show you from in detail lah. You might find it bored. Okay. Now, how about the flow area of all this? Alright. So here's the thing. I think you have to find one by one because you have different slope, right, at the side slope there. So since you have different slope, you probably have to consider one by one. So let's start with A1. So you are going to find A1. I'll just write it A1, A2. You have 6 of them, right? All right. Just now, Priya, you are asking me question, right?
Yes, doctor.
Okay, Priya, help me solve A1.
A1, BY. B1,
Okay, great.
Y1.
Yeah, great. Thank you. Priya, again, A2?
A2. Half ZY square.
Correct. A3, Priya?
Half ZY square too.
A4, continue.
B4, Y4.
B4, Y4, okay. All right. Yeah, you can do that too.
Half ZY square.
Okay.
Same thing.
Okay, great. Okay. So, Priya, help me continue, eh? So, I need this.
30 times 3.
Okay, yes. Got it. Then,
Half times 3 square.
then
Mm,
I just follow your number, eh? I don't know whether it's
half
correct.
2 times 3 square.
Okay, 2, 3 squared over 2. Now, your B4 will be?
My B4.
It's actually this value. Am I right? It's actually this value.
Yes.
So, what is it?
45, 45.
Yes, 45, eh? 9 plus 30, 39 plus 6, 45. So, 45. Y4 would be?
0.6.
Okay, great. Z5?
Half 100 times 0.6 square.
Okay. Y5 0.6 squared divided by 2, 25. 0.6 squared divided by 2. Sorry about the, I don't have enough space. All right, so help me. This is 0.6. Everyone help me. Whoever can give your answer fast is good for us.
The total is it?
Yeah, total.
I got
Okay.
162.
162? I got 121.2.
Oh, maybe
Eh,
I
sorry. Once, yeah,
Perimeter.
you're right. You're right. That is my P.
I got 162 also.
Okay, good. You're right. Okay, you're right. I've been looking at water parameter already. Okay, now, so this is your flow area, eh? So you got it. I think you guys, your group is quite fast. You can do this very well, very fast. Okay, now the next question would be the water.
Doktor,
Yes, yes, saya.
saya tak faham lah yang 45 tu, yang B4 tu.
Okay, ini nak cari area ni
Ah,
kan?
nak cari area.
Betul.
Area B4, Y4.
Kan, nak cari area ni kan? Betul kan? So, nak cari area ni ialah lebar ni darab dengan tinggi kan? Okay. So, lebar ni sebabnya ialah Z2Y2 tambah B1 tambah
Oh, okay.
Z3Y3.
Okay.
Okay,
Nampak dah.
dapat Okay.
Okay.
Alright.
Thank
Okay.
you.
Alright. So, kita let's continue. Kita sambung balik. Weighted perimeter. Tadi siapa yang tanya saya tadi? Faris
Ya, saya.
Faris. Sekarang sambung yang weighted perimeter. Okay.
Alamak.
Tak apa. P1 kan senang je. Bagi saya P1.
Sekejap B plus 2Y.
Method perimeter. You nak plus 2y tu kat mana? Sini tak ada perimeter kan? Dia ada kat, kalau subsection 1 ni, perimeter kan boundary. Ni je. Sempadan basah. Betul tak? You tambah by, dia bukan segi 4. Betul kan? Ini tak ada sempadan kan? Dia hanya sini je. B1.
B saja je lah. B saja.
B saja, betul. Sini saja kan, sebab dia ialah perimeter
30
basah
lah.
ni. Ya, betul.
Okey.
Okay. So sebenarnya saya letak B1 dulu pun boleh lah Okay. Nak tengok formula dia. Tapi kalau you nak letak terus 30 pun tak ada masalah. Okay. Cepat sikit lah. Alright. You guys dah tak nampak kejap Okay. Harap nampak Okay. Now. So, saya ada P1 30, P2. Faris sekali lagi P2. Tak apa, tak apa. Pelan-pelan. Ni.
P2 tu yang serong tu kan?
Ya,
Mana
betul.
tu dia? Okay, Y2 tu 3.
Betul.
Z2 square tu kita pakai 3 square.
Sekejap. Okay. Betul.
Saya tak jumpa formula, saya tak hafal lagi.
Tak apa. Memang
Lambat
ada
sikit
jadual
datang.
dekat jadual pun. So, yang ini sama dengan ini Okay. So, nanti you kira yang ni je lah Okay. Now, P3. Sambung, Faris.
P3 2.
Kenapa 2
Sebab yang 1/2 tu kan yang dia punya
kan?
apa tu?
3.
Yang dia
Why
sekarang ni
dia
formula dia
3. Dia 2 square.
Ya,
2
betul.
square lepas tu 3.
That's why sometimes saya suka you tulis ini dulu tau, formula ni dulu. Tak apa. Kita cuba kan. Ini yang Z-nya kan. Okay. The rest of you saya harap faham Nanti you tulis balik, you tulis formula. Tapi sebenarnya nanti saya akan share slide saya. Slide penuh chapter 1 dengan solution ni lah. Supaya memudahkan you all Okay, ni dah betul. Now, P4 berapa Faris? Sambung.
P4.
Ha.
P4.
Ada tak P4?
P4 tak ada, dia tak sentuh dengan
Betul, tak ada sempadan
saluran.
kan? Betul, dia tak ada sempadan. So seterusnya P5. P5 Faris dah boleh buat cepat kot?
Sekejap saya loading ni doktor.
Tak apa, pelan-pelan. Yang lain bantu Kalau rasa Faris tak kena tu bagi jawapan you all.
P5 0.6.
Alright.
Square root 1 plus 100 square.
Okay, bagus. Sambung, habiskan.
0.6 juga.
Alright.
1 plus 25 square.
Okay. Bagi jawapan terus. Semua tolong kira correct. Wei Jing, you're right. Let's just say we are not sure we are right yet, but your answer is the same as mine. But let's look at Faris' answer. So this is what Wei Jing already got, eh?
Saya tak dapat tu. Sekejap, saya tengah berdebar
Tak apa, pelan-pelan.
Takut doktor tanya. Saya tak boleh jawab tau. Kalau saya seorang-seorang saya boleh buat kot.
Tak apa, yang lain pun sama ke? Tengah kira juga ni. Saya
Ah,
bagi 2-3 minit lagi. Buat je dulu. Pastikan you all tekan calculator Ni buka kurungan, tutup kurungan sebab dia punca yang ini dengan ini. Auni, thank you. Dapat sama
Salah.
Fakrun ada jawapan ke Ahmad Fakrun ni?
121.21.
Okay. Fakrun Naim pun sama Okay. Thank you.
saya tak dapat lagi ni.
Tak apa. Faris, nanti kita sambung Faris. Nanti
Okey.
nanti Faris cuba kita teruskan dulu
Okey.
Sebab jangan risau, benda ni ada nanti. Ada lagi. So esok lusa saya tanya Faris lagi.
Jangan tanya semua.
Bagi gementar tu hilang Okay, now the next part would be part B kan. Soalan ni kata kalaulah Q, if the rate of flow is given as 1.25 meter cube over a second, alright, determine the state of flow. This is what we have learned just now, alright. We have learned about Reynolds number.
Doctor.
And yes, saya. Yes.
This question is activity 1.5.
It's different, is it?
Tadi
Yeah.
1.5.
Yeah, it's different.
Oh, okay. Oh, sorry. Okay. Determine the state of flow. 1.5
Yeah.
This is not 1.4 meh?
No, the 1.5 is other features.
Okay, sorry. You are right. This activity, okay, I got confused. Now, let's go back to 1.4 then. Alright. Aduh. I get mixed up already Alright. Okay, thank you Jin Xiang. Okay, we are supposed to look at this but we have solved activity 1.5. Sorry, doktor tanya macam mana dapat 0.6 tadi. Okay, saya jawab saya jawab untuk Fatimah dulu Fatimah ada kat sana kan Fatimah? Mungkin tadi saya tersilap tengok soalan. Saya tengok soalan activity 1.5. Kalau Fatimah baca soalan 1.5 tadi, dia kata total depth of flow is 3.6. Jadi kalaulah the main channel tu portion dah bagi 3 meter, selebihnya 0.6 meter. Boleh? Fatimah? Boleh tak? Fatimah?
Hello.
Ya Fatimah. Saya pergi soalan activity 1.5
Kejap. Macam mana doktor?
Macam ni tengok activity 1.5. If you look at if you read the question right, it says depth of flow is 3.6. So kalau tengok dekat Fatimah nampak slide kan?
Nampak.
Okay. Tengok dia kata total depth ni 3.6 kan? Ni. So kalau dia dah bagi 3 meter sini ialah
0.6.
Yes.
Okay.
Boleh eh?
Boleh,
Alright.
boleh. Thank you, Doktor.
Okay. So kita pergi balik 1.4 eh. Alright. Now, sorry, just now I think I look at activity 1.5 question already. So let's go back to this question. If you can solve activity 1.5, I 100% believe you can solve this question already. Okay, now. So this is activity 1.4. All right, I need the question. So you will have, now this is the channel dimension. The channel dimension is 0.6 meter with bottoms width 0.5 meter. I directly change it into meter already. It's easier. And you have side slope is symmetry, both side 1.5 Z. But the depth of flow is, all right, this is given as 0.57 meter. Okay. Now, the question asks us to find the top width. Okay. So let's solve for it. Jin Xiang, can you give me the top width?
T plus T equal to 2zy plus b.
Okay. Okay. All right. T equals to 2zy plus b. So, am I right? Am I correct?
No.
Okay. This is 0.57.
Yes,
All
57.
right. Great. So, what is the answer of top width?
2.21 meter.
Okay. Great. Thank you. Now, for those who don't understand, 0.57 is actually y, the depth of flow. 0.6 is actually the height of the channel. So it's different. I hope you'll be careful of that. So the flow area. Jinsan, could you continue this one?
Zy square plus by.
Okay, you're using it the other way. Okay, fine. All right. So this would be 1.5, 0.57,
square plus
right?
0.5 times
Okay.
meter.
All right. Okay, what's the answer?
0.7724 meter square.
Okay, great. Thank you. Okay, so now I need a different friend. Hisham Hussein. Hisham?
Yes.
Okay, Hisham bagi formula vector parameter.
B plus 2y square root 1 plus z square.
Lajunya. Okay. So tak payah tengok rajah dah Saya nak atas dah Jawapan dia Hisham?
2555.
Huh? 2000. Oh, you are using millimeter, is it?
Yes.
Okay, great. But if you can,
Oh.
it doesn't matter. If you write millimeter, you give answer in millimeter 2555 is okay too. I'll give you full mark because the question doesn't ask you to give me in meter. It doesn't matter. All right.
Thank you.
Okay, sometimes it's easier to change it to meter. You have smaller number, but it's fine. All right. So, tak kisah kalau sebab soalan dia tak minta bagi dalam meter, so I don't mind. But you see, hydraulic radius would be A over P. So we have I'll just straight away give the answer. Okay. Now this is not diameter. Alright, this is hydraulic depth is given as A over T, which is still, so if you get A wrong, both would be wrong already. So I hope you be careful. So T would be 2.21. This is 3495 meter. Alright. So, okay, now you are done with the first part. The second part would be actually the question say, if your Q is given as 1.25 meter cube over second. Now, this is the reason why I changed the unit to meter. Earlier, I don't want to use millimeter. Because if you look at the second part of the question, kadar alih dia dah bagi dalam meter. Meter padu per saat. Jadi sebab tu saya tukar teruslah kepada meter dalam soalan pertama tadi. So now the question asks determine the state of flow. Soalan ni tak cakap nak suruh cari Froude number ke Reynolds number, tapi kita dah belajar dua-dua. Jadi kita cari untuk dua-dua state of flow. Now we have Froude number, we have Reynolds number. Kinematic viscosity is given. So let's try Froude number first. Can I have, siapa nak panggil? Siapa nak volunteer? Jaswin Murugia? Is Jaswin there?
Yes.
Okay,
Yes, madam.
Jaswin. What is the formula for Froude number?
Froude number.
Yes, Froude.
V over square root of GD.
Alright, thank you. So what is the velocity here? Velocity is equal to what? Q is given, right?
Q over A.
Yeah, thank you. Who's that?
Fatima.
Fatima. Okay, thank you, Fatima. Okay. So, Fatima, jawapannya berapa? What is our
Saya dapat 1.618.
Your velocity ya? Betul. Sama dengan saya okay. Okay, Jaswin. Continue,
Yes.
Jaswin. Fatima
Yes,
has
madam.
helped you with your velocity. So, what is your gravitational acceleration? G?
9.81.
Okay, great. The hydraulic depth, we already found it earlier, right? Which is 0.3495. Okay. So, tolong selesaikan ni. Froude number. So, siapa pun boleh. Yun Tipo. Tipo?
Yes, madam.
Help me solve this.
Okay. Zero point 8738.
Okay. Tipo.
Yes.
What is the state of flow? Kalau Froude number, Fatima, kalau Froude number, apa kategori dia? Apa pengkelasan dia?
Sekejap
Boleh.
Subcritical.
Tipo, I think you got it already, right?
Yes.
It's subcritical. Why? Because the Froude number is
Less than 1.
Great, thank you. So Fatima tak apa So kita just now kita kata tengok formula Froude number ni kalau lah yang ini kecil bahagi besar, Froude number you will be less than 1. That's why it's subcritical. Kalau velocity ni besar bahagi square root GD, maknanya besar daripada square root GD, Froude number akan besar daripada 1, jadi dia supercritical. So if it's equal, then it's critical then. Okay, there you have it. Now, we are done with this. There's another dimensionless number that we have learned, which is the Reynolds number. This would be new, I'll show you how this is new, how you know how to pronounce all these symbols. Later I'm going to show you. So yang ini, okay, we have our velocity times hydraulic radius, and our new is given as, alright. Saya nak minta Nur Atikah Kamari. Nur Atikah Kamari.
Saya, Doktor.
Carikan Reynolds number, lepas tu bagi saya pengkelasan dia. Semua kena standby kira. Kalau you guys kira cepat, kita habis cepat. You all boleh buat quiz cepat. Kenapa Atirah left? Yang lain? Yes, saya?
Jawapan dia?
Ya, Atika.
487,700.
700 Okay. Lebih kurang lah saya dapat 487,658.4. Okay. Okay. Kalau dapat detail bagus lah So you dapat 700 You bulatkan ke? You bundakan ke macam mana ni?
Ada point dia belakang.
Ada point dia Jawapan saya lebih kurang lah saya dapat 658.4. Okay. So ini ialah aliran jenis apa berdasarkan Reynolds?
Turbulent.
Ya, betul. Because?
Lebih daripada
zero.
Correct. More turbulent flow Okay. Because it's more than 12,500 kan? Okay. So you have there. Now, the last part of the question would be, okay. Now, here's the thing, you have this channel. It says the channel is 50 meter long. Okay. Find the total cost to construct the channel. Now, assuming, you don't have any, any channel yet. So you need to excavate for this channel. In order to excavate it, you cannot use the flow area. Instead, you have to use the channels area. Okay, and channels volume. All right. So you have this area. The cross-sectional area, you times the longitudinal length, you are going to get the volume of it. So therefore, after that, you can actually calculate for the cost of constructing this channel because you have the excavation. And of course, when it says lining cost, right, that means you are going to line this channel. You are going to line this channel. How you are going to find the area of lining is you are going to find the perimeter of the channel, not wetted, but perimeter of the channel, you times the length. Therefore, you are going to get this area where you are going to line this channel here. Now, the same process we are going through when the question asks find the total cost. So that means you have the excavation, you have the lining. So what I'm going to do here is, okay, let's just do one by one. So I'll find the total volume of excavation. Volume of excavation. That means I'm going to excavate this channel. So in order to find the volume of excavation, I have my total cross-sectional area of the channel times the length. So I have A, I put here channel not the flow area times L. Alright, the length of channel lah. So therefore this would be can someone give me the formula for A of the channel? Can I do that? Muhammad Azri ada tak? Azri? Piria, are you there? Is Piria there? No one. Soleha ada Soleha? Kenapa semua senyap
Boleh, hello?
Doktor, boleh. Aizat? Aizat?
Ya, area tu
Aizat, boleh tak bagi nak cari volume isi padu korekkan ni? Saya nak cari isi padu korekkan, saya kena cari luas luas trapezoidal, luas saluran ni, okey, luas keratan rentas ni darab dengan panjang dia kan. Jadi boleh bagi data kat saya tak? B ni apa?
B tu 0.5.
Okey, H?
H tu ketinggian dia 0.6.
Kenapa bukan 0.57?
Sekejap, tak tengok soalan. Sebab ni area longkang area tu dia bukan wetted.
Ya, betul. Ini ialah keratan rentas saluran terbuka Okay, so you got it Okay, so Z ni masih samalah sebab side slope ni sama je untuk aliran dan juga saluran dia. Yes, 1.5.
1.5 lepas tu.
Okay, so yang ni dapat berapa? Darab dengan semua ni. Sorry saya lupa nak darab dengan L. So this one darab L. L kita ialah 50 meter kan? Okay. So sekarang volume of excavation dapat berapa?
42.
Terima kasih. Okay. Unit dia berapa? Unit dia meter
cube.
Persegi Okay, meter cube. Alright, so area to be line. Yang ini ialah luas kawasan yang akan dilapik Okay, tak kisahlah konkrit ke apa ke. So P channel darab dengan L So P channel ialah saya buat terus je Kalau yang tak faham tu nanti boleh tanya saya terus kenapa nombor-nombor ni. Okay, jadi saya nak cari perimeter saluran darab dengan panjang, saya akan dapat luas ni luas untuk saya buat lapikan. Saya nak lapikkan konkrit ke rumput ke pun boleh. So yang ini ialah saya akan dapat 133.2 meter kuasa 2 133.2 meter kuasa 2. Okay. Now, cost. Total cost total cost of to construct this channel, okay, ialah dia kata excavation cost ialah RM6 per meter cube. So 6 kali 42 meter cube tambah dengan RM80 darab dengan okay. So jumlah dia ialah 10,000 RM908. Itu jumlah kos untuk construct channel tersebut. You all ni tengah buat quiz ke apa Macam senyap je.
Tengah fokus.
Oh, tengah fokus Okay. Alright. Ke dah start quiz dah? Tak
Belum
sabar-sabar.
lagi.
Belum.
Okay. Alright. So, it's already 12 o'clock So, I guess this is the end, should be the end of our lesson already lah. Correct lah? Okay. Now, selepas ni, please attempt on the quiz. Masa tutup ataupun tarikh hantar ialah pukul 2 petang hari ini. Tak apa, Azri, tak apa. Don't worry. Pukul 2. Kemudian ada assignment 1 kan? Bab 1 kan? So, I want you to submit assignment 1 by next Sunday. Sebab assignment biasanya 1 minggu saja selepas kita habis chapter. So, I hope to get it. Kalau nak submit awal pun tak apa sebab author you boleh submit bila-bila submit it in PDF lah, easier for me So, ada apa soalan tak untuk hari ni?
So far so good.
So far so good Okay. Alright. So, kalau gitu cuba quiz I wish you the best of luck Okay. Try on the quiz. So, I'll see you Wednesday then for chapter 2. Okay? Alright. Okay.
Doktor, soalan quiz kat author ke?
Soalan dekat author. Soalan kat
Thank
author.
you, doktor.
Alright.
Thank you, Doctor.
Alright.
Thank you, Doctor.
Thank you, doktor.
Thank you, Doctor.
Kalau ada soalan tentang quiz yang ada masalah tu, tanya saya dekat group
Okay, doktor.
Sebab saya rasa group semua dapat
Thank you, Doctor.
You're welcome.
Thank you, Doctor.
You're welcome. Prakru Naim, Faizul, Farah, cuba quiz Faizul?